Alright, so now we're at a second video on the exam for review, starting at number 4. So to find E, you just use second ln to the first power and you get 2.7183. Notice we're rounding everything to 4 decimal places here. You should also be able to plug in -2 and you get 13153. I'm sorry, 1353. Be careful when you get to C. You got to watch, your calculator is going to follow the order of operations, so you'd want to put it in. You do the second ln and you're going to take e to the 0.017 times 15 power. You want to put that in parentheses if you're working on a TI-83, or just be careful that it's taking everything in the parentheses as a power. So there you get 1.2905. On letter D, first you want to change that to e to the 1/3 power. And just remember, when you put that in the calculator, 1/3 should be put in parentheses as 1 divided 3. On some of the TI-84 calculators, you don't have to worry about that kind of stuff, but the TI-83 you would. So just be careful. That's a common thing you got to watch, is that your exponent is put in parentheses depending on what you're doing, if you're doing some kind of multiplication or division. So there you get 1.956. Looking at letter E, so you can see again you want to put it in as 12 times 8 as your exponent, and again with the TI-83 you're going to need the parentheses there, and so that's the answer for that one. F is very similar. You get 8,753.3625. Everybody has a log button on their calculator, and you can just put log 7 in there. And if you look at letter H, you want to change that to 5 to the 1/2 power first. Although actually you could put it into your calculator using the square root symbol, so I guess it really doesn't matter. Either way, you should get 0.8047. Looking at letter I, you can see that you're taking the log of a negative, and hopefully you recall that you can't take the log of 0 or a negative number, and so this is going to be undefined. So again, that you cannot take the log of a negative or 0. You can only take the log of a positive number. On letter J, you'd want to put that in just like it looks with the parentheses around the 2, and you shouldn't have any problem with that one. Just remember on K to put 5, 6 in as using division, and you should get 5.2092. Alright, so let's look at number 5 now. So one of the things I point out is the importance of being able to go back and forth between logarithmic form and exponential form. So here we're changing to exponential form. So again, you need to know your 3 parts. Of course, 4 is your base, and 3 is the exponent, and 64 is what I call the answer. And the logarithmic form will have the same 3 parts. Usually what I do is I write log first, and then my base here is 4, which is, I call it the little guy. The exponent always goes by itself on the other side because a logarithm is an exponent or equals an exponent. And then the answer, in this case 64, goes right there. So I like to do that where I start at the 4, I go around the 3 to the 64. This is my check. 4 to the 3rd power equals 64, which is what we started with, so we're good. Alright, so on the next one, we're going to write log. Our base is 25. We'll put the 1/2 on the other side, and our answer goes there, which is 5. And letter C, you should get log base 3 of 10 equals 2x. Notice here, this is a base 10 log, and so you should get base 10 log, log of 18 equals x minus 5. And I'm going to rewrite this without the 10. And then finally on the last one, this is a base e log, and let's see, our answer is y plus 9. That'll go right there, And of course the exponent always goes by itself on the other side. And again, this should be written using the natural log form ln. And so let's move on to number 6. Now we're going the other direction. So again, we have the same three parts. Notice on A, our base is e. So again, we can take e to the 7th power, and that should equal x plus 6. So again, that's one way to do it visually. On part B, we have 3 to the y power equals x. Letter C, we have a base of b to the 8th power equals an answer of 3/5. And D has a base of 10, so 10 to the r plus t power is equal to s. All right, let's look at 7 now. It says find the exact value without using a calculator. So the main thing we want to remember is that a logarithm represents an exponent, and it gives you all the information you need to know what the exponent is. So on letter A, our base is 3, and what we want to know is what exponent do you put on a base of 3 to get an answer of 1 over 27. So basically in my mind I'm thinking 3 to some power equals 1 over 27. What is that? Again, we're looking for an exponent. Well, the exponent you put on a 3 to get 1/27th is going to be -3. We know 3 cubed is 27, so 3 to the -3 would be 1/27th. So we get -3. Now in letter B, I want to change this radical form first. Anything that's a 4th root can be written to the 1/4 power. So this is b to the 1/4 power. So notice here, I want to know, again, this logarithm represents an exponent. What exponent do you put on a base of b to get b to the 1/4 power? So really, that's just 1/4. The other way to think of it here, again, is what exponent do I put on a base of b to get b to the 1/4 power? So again, the exponent we're looking for is 1/4. On the next one here, we're looking for the exponent you put on a base of a to get an answer of a. Well, that's just going to be 1. On letter D, again, the logarithm represents an exponent. It's the exponent you put on a base of 8 to get 1. And of course, anything to 0 power would be 1, so this is the exponent 0. By the way, you can also check these. If you take 8 to the 0 power, that does equal 1. All right, let's look at E. So 6 to the what power gives you 0? Or what exponent do you put on a base of 6 to get 0? Well, 6 to the first, well actually, we should probably think back to what we said earlier, or what I said earlier. We can't take the log of 0 or a negative. And in fact, there is no exponent you could put on 6 and get 0. So this one is not defined. On letter F, we're looking for the exponent you put on a base of pi to get pi to the 9th. That would just be 9. These last three are a little bit tough to see. You have to really know your exponential and logarithmic functions well. Think about what ln of 23 means. It's the exponent you put on a base of e, because our base here is e, to get 23. It's the exponent you put on a base of e to get an answer of 23. Well, since we're putting it as a power on e, the answer here is just 23. Letter H is very similar. So I'll say this one more time. Hopefully, if it didn't click on the last one, hopefully it'll work here. So log base 2 of 59 is an exponent. It represents the exponent you put on a base of 2 to get 59. Well, we're putting it on a base of 2, and so we're going to get 59. All right. So this last one here, notice the stars. This one's definitely more involved. Really, these last three you're not likely to see on a test. If anything, I'd put it there as extra credit. Let's look at I. So this is the exponent you put on a base of 4 to get 32. I'm going to go ahead and say this is equal to x, and let's write it in exponential form. So we have a base of 4 to the x power equals 32. So now we can think back to how we're going to solve exponential equations later, but one of our techniques is to get our bases to be the same. Well, we can't write 32 as 4 to some power, so we have to go smaller and change both of these to a base of 2, because 4 can be written as 2 to some power, and the same thing's true with 32. Of course, 2 squared is 4, so I can write the left side as 2 squared to the x power. And if you look at your powers of 2, you find that 2 to the 5th power is 32. So I'm going to go ahead and, when you have a power to a power, we use the power rule and we multiply the exponents. So you get 2 to the 2x here is equal to 2 to the 5th power. So notice we have the same bases, and these two exponential expressions are equal. So the exponents must be equal. So 2x is equal to 5. And so we're going to get 5 halves. And so that's our answer here. All right, let's look at number 8. It says find the domain of the following functions and write your answer in interval notation. So first of all, I want to remind you, if you're graphing a logarithmic function like log base 6 of x, here we have a base that's greater than 1, and so we know it's going to go through 1, 0. It's going to have that shape there and an asymptote at x equals 0. That's our basic logarithmic function. But the key here is, for that function, notice that x has to be greater than 0. We've talked about this. You can't take the log of 0 and you can't take the log of a negative. Whatever you're taking the log of has to be positive. And so now in this problem we have f of x is equal to the log base 6 of x plus 3. So I need to be taking the log of a positive. I need x plus 3 to be greater than 0. So let's solve for x. We get x is greater than negative 3. Now remember, we're supposed to write our answer in interval notation, so the answer is negative 3 to infinity. Alright, let's look at b. So again, we'll set 2x minus 9 to be greater than 0. So let's go ahead and add 9 to both sides. We get 2x is greater than 9. We'll divide by 2, and so x is greater than 9 halves. And so in interval notation, it's 9 halves to infinity. So we can't pick 9 halves. If you actually put in 9 halves, you would see that you'd be taking the log of 0. If we pick anything bigger than 9 halves, we're okay. Say we pick something less than 9 halves, like 0, then you'd have 2 times 0, or 0 minus 9. Notice you'd be taking the log of a negative. So as long as we pick something bigger than 9 halves, we'll be taking the log of a positive number. And so that's our domain. Alright, as we do number 9, notice we're going to be, this is where we have to, they didn't use the word that we used before, but we're going to expand these logs into 2 or more logarithms. So basically we're taking a single expression and expanding it using our 3 properties. So I'm going to go ahead and put them down here. We have the first one is the product rule, where the log of a product, m times n, is equal to a sum of logs. On number 2, you have the log of a quotient is equal to a difference of logs. And then finally 3, the log of some m to some power can be rewritten using or putting the power first times the log of m. So we have the product rule, the quotient rule, and the power rule. Alright, so let's go ahead and get started. The thing you have to remember with these is that you got to go in the correct order. So on letter A here, notice we're going to need the first rule because we have a product, and we also have a power. But see, the x to the fourth there, the 4 only goes on the x. It's not an exponent on the 7, just the x. And so I can't just pretend that this 7 is not there and move the 4 out front. Hold on a sec. If you look at what we have here, it's just a single base to a power when we move the power. And that's not what we have here, so we're going to have to use the power rule first. I'm sorry, the product rule first. So let's break this into a sum of logs. And see, now I can pull that 4 out front using our third rule, or the power rule. And so we get log base b of 7 plus 4 times the log of x. Whoops, and I forgot my b there, didn't I? Let me go ahead and put that in. Alright, let's move on to b. So in this problem, I've got a product 5x squared, and also I've got an exponent on the x, but I've got that radical. I really need to take care of that first because I really can't get to the product. So we're going to have to use rule 3 first. Notice I've rewritten this as 5x squared to the 1/3 power. Anytime we have a cube root, we can write our radicand, or what's under the radical, to the 1 over whatever the root is, in this case 3. In this case, our answer would be 1/3 power here. So now we want to go ahead and use rule 3 and pull that 1/3 out front. And so now we can use the product rule. So let's go ahead and break this into 2 logs. Now notice I put parentheses around this, and that's because I have 1/3 times this single log, and if I'm going to break it into 2, the 1/3 is going to have to be distributed. It's still times whatever the natural log of 5x squared is. So if I break it in 2 logs, I'm going to have to put that in parentheses. At some point we're going to distribute the 1/3. Alright, so let's go ahead and if you look at natural log of x squared, now we can use rule 3 again. And so we'll pull that 2 out front. And now I'm going to go ahead and distribute the 1/3. 1/3 times the natural log of 5. We'll just have 1/3 natural log of 5. But notice when we multiply 1/3 times 2ln of x, 1/3 times 2 is 2/3. And so we end up with 2/3 natural log of x at the end there. Let's look at C. So we've got a power in the numerator and denominator. We've got a quotient. We've got the product rule going on here because we have 7 times z cubed. But again, the only one that we can really use to start would be the quotient rule. Like, you just can't ignore this whole numerator and use the product rule in the denominator there. We're going to have to use the quotient rule first. So that's property 2. So it'll be the log base 5 of x plus 2 to the 4th minus log base 5 of 7z cubed. And so let's see, I'm going to go ahead and use the power rule, or rule 3, and move that 4 out front on the first one there. And then notice on the second log, I've got the log of a product, and I'm going to go ahead and use the power rule, or I'm sorry, the product rule there. So again, I'm going to need parentheses here because it's minus this single log that I just broke into 2 logs. So the minus applies to both of these logs. And let's see, now we've got that log base 5 of z cubed. We can pull the 3 out front using the power rule. So we're using all sorts of, we're using all of our rules, in fact, even more than once, certainly with the power rule. So let's go ahead and do that. So we've got 4 log base 5 of x plus 2. We're going to apply the minus to the log base 5 of 7. And then we've got to apply the minus to the second log there, but we're going to pull the 3 out using the power rule. And that should do it for us. I think we got everything we need. Alright, so let's look at D now. Again, we're going to have to use the quotient rule first. So let's go ahead and write that as a difference of logs. And for the first log there, I've got a product, and I can't deal with the powers until I break this down using the product rule. So rule 1. And now I'm going to go ahead and use the power rule, rule 3. And that's going to be our final answer there. And I'm going to go ahead and stop the video here. And this is part 2.